Hey everyone, welcome back to Lofi Startup. Today I'm joined by Michaela and Ryan, some colleagues of mine, and today we're chatting about our Lofi production deployment pipeline at our startup. A couple of things we're going to chat about, hopefully gives you guys some inspiration for your own deployment pipelines, and maybe what future steps could be as your team grows and the demands of your product engineering team expand as well. So yeah, let's get into it. Okay, so the first thing we're going to chat about is what do production pipelines look like for small teams, and what's the sort of general steps you could take maybe as a first-time startup or small engineering team looking to develop a deployment pipeline strategy for your company. Ryan is our lead engineer, CTO at our company. He takes care of our deployment pipeline, making sure that everything gets pulled into production smoothly. Just generally oversees the process for our team. We're a team of 6 engineers. Really have anything fancy going on.
We're basically a one-man show on DevOps. It can be very simply broken down into what are the necessary steps to get your code that you are making changes to and wanting to deploy, where you're wanting to get that to first of all. So it starts with asking yourself, where am I going to host this and how do I want to host it? For us, that looks like hosting it on AWS's cloud services. When you're running your code locally, you're basically hosting it on your local host. You then want to get that instance into a remote location. That's why you would choose a company such as AWS or Google or Microsoft Azure. I mean, if you're going super lo-fi, super custom job, you can host it on your own machines.
Totally.
They're just gonna have to be running all the time. But to get your changes in and to deploy and create a pipeline thereof, that's going to take a couple factors into account. Your Git repository is a great thing to use for triggers and actions to kick off deployment pipelines. There are also a bunch of deployment services that one could use to automate that, or it can be a very manual approach where it's just like you're maybe not deploying tens or hundreds of times a day.
For sure.
And you don't have thousands and thousands of people working for you. So it's like, cool, this is not really warranting a completely or fully automated process.
100%.
We are still somewhat in that area of our deployment journey. A lot of that is actually just manually kicking off a script that automates most of the logic behind committing and doing version updates, just so that you keep track of your semantic versioning, and then also pushing those changes through and tagging your work so you keep a good history, because that's another thing I think that's very important.
Totally,
Especially if you need a rollback.
Yeah, especially if you need a rollback.
Crisis. Take it off.
Okay, so to summarize that first section, basically the two first things you need to think about is where exactly are you going to deploy your code to? What maybe cloud services are you going to use, or are you going to do something on your own machines? And then secondly, how deep should you go in terms of the size of your team, and maybe what sort of automations you want to include. And what we found is starting with something super minimal, nothing too fancy in the beginning, kind of helps just to get the ball rolling, get into a regular cadence of builds, and not really stress too much about plugging in so many different automations and tools, and because there's so much stuff out there and it can really kind of get quite exhausting. So the next thing we're going to chat about is, once a feature or patch is ready, what steps do we take as a team to now get that pull request into our development branch, and then the steps from there to basically get that into production. So Michaela works on a lot of patches and features daily in our business. She's going to chat now just a little bit about what that process looks like in terms of when something's ready, what do we do from there in our team.
As an engineer, mainly working on the API, developing features and patches that serve our user application and some other peripheral features that we use. I would just make my feature that's needed with the spec, and then once it's done and I've tested it and I'm happy with it, then this is all happening on a separate branch, branched off of our main development branch. Firstly, I make a PR request, and then I go to the Slack channel. Then I request deployment, and I link that PR request, whether it's a feature or a patch, a description, which of our servers, since we have 3 different servers.
We all have our own emoji to basically approve the deployment. We all have this mini internal challenge.
Who can approve
the fastest?
And can you approve it faster than the person actually making the request? That's
But Ryan has an unfair advantage because he sees the PR before anyone, because you have the GitHub app on your phone.
So
Michaela will be I'll be sitting next to Michaela ready to add my coffee emoji. I'm ready to go, and Michaela submits the Slack message, and as I'm about to hit the emoji, Brian's emoji is miraculously already there.
Yeah.
I'm waiting. I see the PR already on GitHub.
It's crazy how Ryan always manages to win that competition. But anyway.
And then after that, once Ryan deploys it, there'll be another message deploying PR, the number, the version that we're doing, and then some indication markers in the form of emoji.
Merged PR, currently building the Docker image, successfully built the Docker image, and then taking that image and bringing it into our deployment environment, creating a container for that. The last one is successfully deployed to dev or ops or prod, depending on what the emoji is.
The emojis are quite nice because at a quick glance you can see where's this build in the pipeline and which environments is it now live on. So often Michaela and I are working on a feature together and we want to test it in the dev environment. As soon as I see the little rocket emoji, I know we're live in dev. We can connect to dev from one of our front ends or client applications, and we can just start testing, which is really cool. It's a very simple line of sight and visibility into just there's one location and everything is monitored in that location, from the pull request to the deployment itself, and then to the success or failure of that actual feature patch.
Again, it's also a place where we are keeping a history or some kind of log. So commit messages or just a description of what's going in. And we can say, oh, this is the service that's maybe problematic. Let's roll back before we push that change without then having to go all the way into Git and scrolling through everything.
And it's also fun, like emojis are fun. So.
We love emojis.
Okay, so we chatted about our process of how we submit a PR, approve a PR, and our sort of Slack channel environment where we monitor the progress of a build and the success and failure of a build. What we're going to chat about now is that process from pull request approval to actually deploying code onto our different environments. Dev for testing, prod is our main resource server, and then we have an ops server which is for things like cron jobs and bigger sort of computationally heavy tasks that we just have a different CPU and RAM setup.
Configuration. It's where we need to be more vertical than horizontal.
Yeah. What's kind of the main steps that you take there?
We have a certain level of automation that happens. Automation always becomes a necessity as you grow larger and larger. And we definitely got to that point where it was like, cool, running each script, even if I have like a command line autocomplete and it recognizes what I'm doing, it becomes a bit much. There is a level of automation, but it's like a shell script over what you would more commonly get, which would be some kind of YAML documentation. For us right now, we currently take our Node environment, this is for our API specifically, that we're going to be taking to the dev or the ops or the production environments, or as we would call them, namespaces, because we currently making use of the Kubernetes infrastructure, and we Dockerize our API to a Docker image. We then tag that image, which is saved on our Docker Hub repository. We use that tag to identify what image we're going to be pulling at any given moment. So currently, when we're wanting to take something to production, after the deployment request is sent, we build it into a Docker image, and then we tell Kubernetes, hey, that Docker image is now ready to be fetched. Pull in that image, use that to create a server instance, basically install it into all the different machines that we have in our Kubernetes cluster. We have 3 different environments, as we said. We don't actually have a pre-environment, which is not yet, but it works for us, just having that kind of basic setup and configuration. There's less points of failures as we stand right now, but sometimes you do want a couple more points of failures in your pipelining. If you need to create an image that has to be compatible or configured in such a way, Docker made that a lot easier for the average person to actually create that configuration that can be replicated again and again. When Docker came into play, things such as creating clusters with the ability to horizontally scale.
Yeah.
It created that path to be a lot more easily accessed
For sure.
by people. Your server configuration, controlling the environment and sort of climate that you're going to be running your instance on. Docker really did change the game big time. For example, still locally, we're building our Docker images.
Yes.
But we are building it for an x86-64 like Linux environment.
Totally.
But it's still being built on an ARM 64 architecture.
Yeah.
Docker makes it pretty easy for you to specify what architecture you're going to be building for. You can create your own little mini pipeline in your Docker file already.
Totally.
So you can use a make file to basically combine everything in the configuration that you're looking for and run that as an entire project, linking what needs to be linked, installing what needs to be installed. Docker does the same thing. So it's like, cool, make sure the environment is set up like this by running these, usually just shell or Unix commands. Create this as the environment that the server will run in. We use EKS Fargate instance, which is our cloud infrastructure that's being hosted on AWS. What our Kubernetes framework allows is for us to create many different pods.
Pods are just our instances of servers running.
Each pod is literally a container for that image that we are pulling from Docker to run in.
Yeah.
It gives us a very wide bandwidth that we're not going to be bottlenecked should we have all of a sudden massive user growth like we've seen in the past. And then we're sort of getting choked because there's only so much availability.
Yes, 100%. So the main sort of benefit with Kubernetes is that ability to horizontally scale pods as opposed to vertically scale compute and resource power.
Yes.
And it's great for, startups who have product market fit and now are scaling potentially and need a quick toggle to sort of spin up new instances and make sure there's no downtime. And I think it's just really great to scale an API.
It's also, it can be very cost effective.
Sure.
I mean, maybe not as cost effective as like creating a whole Lambda service for running only when it needs to run.
Yeah.
But it's pretty amazing just how much control you can have.
To summarize that section, Docker and Kubernetes, which we use at our company, great choice for firstly getting the environment you actually want with Docker, making sure that your code can run pretty much anywhere and on any machine or architecture. And then secondly, using something like Kubernetes to assist you with seamlessly scaling up your production resources, not run into headaches when it comes to making sure there's availability for your users. Having things packaged within a cloud environment like EKS, you have all of those things working nicely together. You've got the load balancer, directing traffic to different pods. You've got Kubernetes running to scale up and scale down those pods accordingly. And you're really in a nice sweet spot to kind of just move quite quickly when it comes to running your services in production. Another thing that Ryan and I identified with Kubernetes, which has been a really helpful tool for our business, is something called an HTTP probe, which is essentially a very high frequency health check on your pods to basically automatically restart them. So initially we were having some trouble in production. We had some code that was crashing our server and we would sit and manually restart pods. And this is just what you do, if you're a startup, you're using the app, and then I would phone Ryan and be like, hey dude, please restart the pod.
I would be like up at 2 a.m. being like, flip, I hope everything is okay. Let me just check our dashboard.
So when you are setting up Kubernetes instance, I think a nice quick win would be to add an HTTP probe,
Yes,
a Liveness probe. Quite quick to get it set up.
It is very much just a quick win that you can configure within whichever namespace you're wanting to run it for. You literally just go into the config for that, and it's very well documented. What you also want to actually do, first of all, is expose an endpoint on your system. You just call like /health or something.
100%.
And that will just send back a 200 if it's good. If it's not sending back anything or any other kind of status number, then you know that something is wrong. When our pods were just stopping altogether, we were like, cool, what can we do? And we found out about these liveliness probes. Cool, that is an unresponsive node on the network, restart it. You'll also see like it actually keeps track of how many restarts. If you see there's a high volume of restarts on any given pod, then it's like, cool, there must be some underlying...
It's an indicator of an underlying issue.
Yeah.
So the final thing we're going to chat about is where do you sort of go from here? Ryan is our CTO and our sort of one-man DevOps engineering team. I'm sure, he has a lot of plans for where we go from here and what other tools and strategies maybe we would adopt. But the main thing is, what works for your company at any given point, and don't try rush into anything. Take it step by step and organically add what you need as you need it.
The developer life cycle is a constant road of learning. If you are maybe less informed and it's not your area of expertise yet, then don't let that stop you from building. I mean, unless you're dealing with some very sensitive information, make sure you're doing it right, and always make sure that you're secure and protecting, if you have users, protecting their information and your own information definitely has to be priority number one. But don't let it stop you from actually growing when it comes to just starting out and building out a project that you've been thinking about and wanting to bring into this world. Saying that, different ways in which you can grow once you have just a basic foundation for your deployment pipeline, like going from cool, I have a way in which I can get my changes up into a remote environment that is accessible to either my app or other public services. And now how can I just improve either the speed and efficiency of that or the security and quality of that process, and also of my system or changes that I'm bringing in. There's a number of steps that you can add, actually. That's why I was saying you sometimes do want a couple points of failure.
Totally,
Some friction points, some
you can't just keep on throwing it up there. You need to really add some rigor once you start scaling. Then the stakes do become quite a bit higher, the risk starts growing.
And reputations are on the line.
Reputations are on the line, exactly.
It's true.
But I would say testing is a must. I would actually say from the beginning. I know it.
How many years were we operating before we have tests even halfway implemented now?
I don't even want to admit it.
A year and a half. We didn't have tests for a year and a half.
Hey, you got to do what you got to do to release your product and
for sure
get it into the hands of users. And maybe that's at the neglect of testing initially, but certainly as you scale in and you have product market fit, it's certainly something I think that needs to be part of your strategy.
And also, we as a community have less excuse now that AI has come into the picture.
100%.
It does the tedious things, and it's yes, you do actually really have to do this, but now it can just be a little bit easier.
100%.
Other things that you can add, once you start scaling and you want a level of automation to be in place, for us, I think that would look like for our API, that could either be going something that's more custom and configurable like Jenkins, or just being no, we don't have a lot that we have to do right now, and there's enough compatibility with other systems like SonarQube or SNCC security where we can just plug them in as integrations into Circle CI or something.
For sure.
But adding first of all passive checkers, I think the deployment line can definitely start there within your own IDE, checking for vulnerabilities just from your imports, and the versionings of those imports would definitely be a big one. And then going a step further, using some kind of additional extension to your deployment pipeline, such as adding code smells. That can be, hey, this is a negative pattern that's being used, or it's not the best practice, or recommendations thereof. Getting some understanding of the quality of code that's going in. Of course, as we said, testing. It's great for having a really good redundant understanding or expectation of the output of your functions and services. And should there be any movement that is not expected, so it maybe is out of scope for the changes that are going in, then something will be, alarm bells will ring and it'll be like, cool.
Testing really helps uncover unexpected side effects.
Yes,
Yeah.
fully. Then when it comes to the actual health of one's deployments, I would say auto-scaling
Yep.
is a very important feature for cost reduction and budget management. And also just, having some kind of dashboard. We have a basic one right now and we're wanting to actually grow that, add on things like Prometheus.
Yeah. Grafana and things like that.
Grafana, exactly.
So just general monitoring on the deployment layer.
Getting an understanding of how your system's actually being used by your users on a very, very much like a hardware level and a traffic level.
Awesome. Thanks everyone for watching. I hope all of this was useful. Yeah, I think really a good takeaway from this is don't overthink things too much. Just start with something, get your code onto a server, get users interacting with your services and slowly iterate from there. And I think we've seen success in our business kind of just taking that sort of lo-fi approach and not worrying too much about things. And there's fun things you can do along the way that are quick wins. Yeah, I really think it's just really up to your business, and this is just our own experience with, what do we know actually? Yeah, what do we actually know?
Be picky, be discerning.
Yeah.
Take what you like and what you think could fit well into your own system or process that
100%,
that you're creating.
And thanks again, guys, for joining me today. And I'll certainly be having Michaela and Ryan back on another episode, and hopefully some more of our team. Super fun giving you guys a sort of behind the scenes look of what this stuff actually looks like. So hopefully it's helpful. If you've enjoyed it, give it a like, subscribe, and we'll see you guys in the next one. Cheers.